going to start our new lesson in physics, motion in one dimension. So let us start what is motion in one dimension and its related terms. So here you can see two different pictures, isn't it? When you closely observe that, you can see above this car what we have written there. Here in this picture you can see it is written 100 kilometer per hour, isn't it? 100 kilometer per hour. But in this picture you can see one more thing we have shown. It is 100 kilometer per hour towards north. So what is the difference between these two? All these things we will be coming across in this video. So before going into detail what does it mean, let us see what are the two types of physical quantities that we come across. First type of physical quantity is known as a scalar quantity. In the first picture I said this car is moving with a speed of 100 km per hour, and this 100 km is the measure of the speed, isn't it? It is the measure of the speed. In physics we call this measure as magnitude. Magnitude is the measure of something. It may be size, it may be amount, whatever it is. It is a physical quantity, that is the measure. And such a physical quantity which has only this measure or magnitude, but it does not say anything about the direction of the car or vehicle or anything, is known as a scalar quantity. So what is a scalar quantity? A scalar quantity is a physical quantity that has only the measure or only the magnitude. It may be size or amount, what it is, but it has no direction. And scalars are described by a single value along with its unit. For example, speed is a scalar quantity which has the measure 60 and its unit is kilometer per hour. And mass, here you have a number and its unit kilogram. Temperature is also a scalar quantity which has its number and its unit degree Celsius. Time, number and its units seconds. So such a physical quantity that has only its measure or magnitude is known as scalar quantity. Now look at the second picture here. Here 100 km per hour towards north. Two things are clearly shown. What are the two things? This 100 km per hour as well as the direction in which this car is going to go. Okay, so such physical quantities which has both the magnitude and direction is known as a vector quantity. It is known as a vector quantity. Okay, so what is a vector quantity? A vector quantity is a physical quantity that has both magnitude and direction. Okay, magnitude and direction. Such a physical quantity is called a vector quantity. And these vector quantities are sometimes represented by an arrow above it. Okay, sometimes it is represented like this. So when we see such an arrow, it shows that it is a vector quantity. And you can see here, this example is velocity. Velocity, we have written the magnitude or the measure 60 kilometer per hour, the unit, as well as the direction 60 kilometer per hour north. So a physical quantity which has both direction and magnitude is known as a vector quantity. Okay, examples and its definitions we have seen. Now, what are the key characteristics of these scalar quantity and vector quantity? First, we said that it has only its measure or magnitude. Second, it has a single number followed by a unit. Single number 60 and its unit kilometer. If it is distance, if it is speed, we can write kilometer per hour. Okay. Operations like addition and subtraction follow simple arithmetic rules. Normally how we add 60 plus 40 it follows this simple type of rule. That's all. Okay, simple type of addition. Next, key characteristics of vector quantity. Vector quantity has only its magnitude and direction both. Okay, vector addition rules. So vector addition rules you will study in higher classes. What do you mean by that? It follows certain vector addition rule as triangular or parallelogram method of addition. So different methods are there that we will be covering in maths in higher classes. And it is often represented in bold letters with an arrow like this. Sometimes it is represented in bold letters, or sometimes with not a bold letter but with an arrow above it. This is how we represent a vector quantity. Hope it is clear. Now we will see what are the main differences between scalar and vector quantity. So definition of scalar quantity, it has only magnitude but no direction. But vector quantity has both magnitude and direction. Examples: speed, time, mass, etc. And examples of vector: velocity, force, displacement. Then representation, only single value 60, right? What I have written here, 60 followed by this unit. Here arrow or bold notation, it has the number as well as the units and direction. Addition, simple arithmetic, but vector follows vector rules. What are these? We will study in higher classes. Okay, next comes to another topic, rest and motion. We say that an object is said to be at rest when it does not change its position, isn't it? That is when we say that that object is at rest. So with respect to time or a reference point, if an object is not moving, then we say that that object is at rest. So if the car, we can say that the car is here and there is a tree, isn't it? So when we checked this, or when we were walking at 10 a.m., we saw this car standing here. When we returned from a place after 2 or 3 hours, still if the car is standing there, it shows that the car has not moved. It is at rest, isn't it? After a few minutes, when we come back, if it is still there, it shows that that car is at rest with respect to this tree and with respect to this position in this turning. Okay, so an object is said to be at rest if it does not change its position with respect to a reference point over time. The reference point here is this tree. It is parked near the tree. Okay, believe if it is parked near the tree, so after a few minutes, if the car is still there, it shows that with respect to this tree, this car is still at rest. A book lying on a table is at rest concerning the table. If the book is lying like this, if it is not moving at all, it shows that the car or the book is at rest. Now we can see the camera is moving but the book is not moving. Table and both the book and table are still at rest. Okay, next one. What is motion, or when do we say that an object is in motion? If an object changes its position with respect to a reference point over time, then we say that the object is in motion. A car moving on a road changes its position with respect to nearby trees or buildings. We can see that, clearly see that we are sitting inside a car and this car is moving, isn't it? With respect to the car, the trees, we feel that the trees are moving back. So what does it show? The thing in which we are sitting is moving. So that is motion. An object is said to be in motion if it changes its position with time. Okay, if it changes its position with time. An object is said to be at rest if it does not change its position with respect to time or a reference point. Okay, next we want to see what is distance and what is displacement. Okay, so let us see a figure here. If an object wants to travel, if there is a car which wants to travel from A to B, we can see that there are two ways. One, this car has to travel in a zigzag manner like this. So it takes 8 kilometers to reach if the car goes by this zigzag road. There is a small road, or it is a straight road, and the distance is only 2 kilometers. So which is the simplest or the nearest way? It is this one, A to B, the straight road. Okay, that is the simplest or the shortest route. So in physics we study two physical quantities. One is distance and the other one is the displacement. So what is the difference between these two? What is the difference between these two? So distance means the total length traversed by the object. So if a car is starting from here, the total distance traveled by the car is 8 kilometers. That's its distance. And if the car is moving in a straight road like this from A to B, the total distance is 2 kilometers. So distance is the total path traversed by the object. And what is the difference between distance and displacement? Still a mystery. Wait. Okay. So distance is the total length traversed by an object along a path. A car travels a distance of 50 kilometers, means that the length traveled by this car is 50 kilometers. We don't consider if it is a straight road, if it is a zigzag road, nothing is considered. Only the length traveled. Then we say that distance is the total length traversed by an object along a path. Okay, displacement. Displacement, it is the shortest distance between 2 points. A to B, it can be gone like this, or A to B directly in a straight road. So displacement is the shortest distance between two places or 2 points. Also, distance we say only 50 kilometers, but when we say displacement, we say that the car is traveling or travel 50 kilometers towards north or south. If along with the measure the distance we say its direction also, then it is called displacement. So displacement is the direction or the distance with direction. What is displacement? Two definitions are there. First definition is displacement is the shortest distance between 2 points, and the second definition is it is the distance with direction. If we say the distance and along with we say that this object or this car moved in this direction, then it is displacement. So displacement is the shortest distance between 2 points. It is also known as the distance with direction. For example, a car travels 50 kilometers towards south. Then that is the displacement. Okay, distance and displacement. From this, can you tell which one is scalar quantity, which one is vector quantity? Yes, distance, it has the magnitude only. So distance is a scalar quantity. At the same time, this displacement has both the number or the magnitude and direction. So displacement is a vector quantity. Okay, is a vector quantity. Now, suppose a car is going from a point A to point B, and the distance between these 2 points is 100 meters. Okay, suppose a car is traveling from point A to point B and the distance is 100 meters. Again, if the car travels back from B to A, same distance, 100 meters, it is coming back. First, it is going from A to B. Second, it is returning from B to A. So what is the distance traveled? What is the distance traveled by that car? We say that the car traveled a distance of 100 plus 100, which is equal to 200 meters, isn't it? But what about the displacement? What about the displacement? we have already said that displacement takes into consideration the direction. So we know that in mathematics or any other, if we are traveling from a point towards the right, it is taken as the positive direction, isn't it? Remember number line. If we are moving from a point towards right, we take it as the positive. Now if we are returning back, we are moving in the opposite direction, isn't it? If we are moving from left to right, it is positive. If we are returning from that point again to the starting point, it is in the opposite direction. So what is the opposite of positive? The opposite of positive is negative. So from A to B, that car traveled 100 meter towards north and it returns again 100 meter from B to A in the opposite direction. So what will be the total displacement? What will be the total displacement? From left to right, from A to B, it is plus 100 meter, but from B to A, it is minus 100 meter, because we are considering the direction. That means displacement is equal to 100 plus minus 100, because we are taking into consideration the direction, which is 100 minus 100 equal to 0. Okay, 100 minus 100 equal to 0. So displacement is 0. Distance is 200, because distance is not considering the direction, but displacement is considering the direction. So from left to right, or from starting to ending, it is positive. From ending to again back to starting, it is negative. From this we can say that this distance can be, or distance is always positive. Distance is always positive. Distance cannot be negative, but displacement can be negative or 0, both. Okay, displacement can be negative or 0, but distance cannot be negative or 0. Okay, so can you differentiate between distance and displacement? Yes, we can. First distance, then displacement. How can we differentiate? We will start with the type of quantity, physical quantity. Distance has only magnitude, so we can say that distance is a scalar quantity. What about displacement? Displacement has both direction and magnitude, so displacement is a vector quantity. We saw that this distance cannot be 0. Distance cannot be 0, but this displacement can be 0 or negative. So these are some of the difference between distance and displacement. Hope it is clear to you. We will continue the next topic, which is about speed, velocity, in the next class. If you like, please like my channel, subscribe. Thank you.